So logarithmic equations, we have several ideas on how we can solve them. So it depends on what they give you. Usually I tell students, do what you can, you know. You have rules and properties, so do what you can. If you can't do that property, you might have to go to another idea. Okay, so the first idea we have um, is that we can convert to exponential notation. So that's the idea here. Now to do that, you're going to have to first isolate the log part, so log base b, then convert it to the other notation. So say you have b of x equals, then you're going to convert, so you're going to go b to the a equals x, okay? So remember doing that, like you go over here and you put it back in. Okay, so you convert it to exponential, and then you can solve, or you might be able to. Okay, but one thing we have to say when we're solving logarithmic equations, you have to check answers. You always have to check the answers to make sure arguments are greater than 0, okay? So don't forget that. So you're going to get all done and you're going to be happy you have the answer, but you have to check it to make sure that in the original it doesn't make an argument negative or 0. Okay. All right, so here we go with these ideas, which, maybe they don't make sense right now, but hopefully after we do these two problems. So I have on A here log base 4, there's the 4, and here's the argument, x plus 3, and then it equals 2. So we take the base, 4, we go across, get that 2, that'll be the exponent, and it equals the argument, x plus 3. Okay? I know what 4 squared is, that's 16. And I can subtract 3 from both sides. So I get 13 equals x, or x equals 13. And you're done. Whoops, I forgot to check it after I made that big deal too. Okay, so does 13 make that argument negative? What's 13 plus 3? Well, that is bigger, that is greater than 0, so this is okay. This checks out. Okay, great. All right, here's the next problem. See the 3 in front? We want to divide both sides by 3. That's what we mean by isolating the logarithm. So the 3's out. Now I have natural log of 2x equals 4. Okay, so that's great. I got the log part by itself isolated. Okay, but do I know the base for an ln? Yes, it's an e, right? You can put a little e there if you want. Okay, so I'm going to convert. E is the base. I go across to get the exponent. So e to the 4th equals 2x. Okay, so however you want to draw it. But that's the definition of how we convert from a logarithm equation to an exponential equation. Okay, now I'm trying to solve for x. Divide by 2. So what's the answer? X equals e to the 4th over 2. You could get a decimal approximation on a calculator. If you do that, it's going to be e to the, and like my calculator has the parenthesis thing, so I'm going to have, you have to go second e on my calculator to get that e to the exponent. I'm going to put in 4, close that parenthesis, and then divide by 2. Divide by 2. And what do I get? It's 27.30, so approximately 27.30 is how it rounds off. Okay. But if they just want the exact answer, that's fine.